Hey guys, Professor Calculus is here, and today in this video we want to solve this integral that I got for you. But before that, make sure to like and subscribe as it is free and you can always change your mind later. So, for this integral, we're going to use the Feynman strict of integration, and as usual, I'm going to define a parameter, and I'm going to parameterize the integral that I had, tx squared over x squared dx. And if I take I prime of t, the derivative with respect to t, I have to take the derivative with respect to t of an integral e to the negative x squared sine of tx squared over x squared dx. And the I prime of t is going to be, and this is going to go inside. Thus, I'm going to have partial t of e to the negative x squared sine of tx squared over x squared dx. Since I'm taking the derivative here partially, I would consider these two constants and I'd only take the derivative of sine tx squared. Thus, it would be e to the negative x squared cosine of tx squared x squared over x squared dx. The t here vanishes because it is we're differentiating with respect to t, and x squared here is constant and is considered a coefficient. Thus, I can suppress these two together. Therefore, my chair is making lots of sound. Sorry if you can hear it. My I prime of t is the integral from 0 to infinity of e to the negative x squared cosine of tx squared dx. And we're going to stop here. And here I'm going to remind you of a formula, Euler's formula, and it is defined as, if I have a number e to the ix, e to the ix term, I can write it as cosine x plus I sine x. And if I plug in here tx squared, I'm gonna get e to the I tx squared equals cosine of tx squared plus I sine of tx squared. Notice that how the real part of this thing here matches the integral that we have here. Thus, I can replace the only real part of that in here. But how do we do that? Do I isolate for cosine of tx squared and say it is equal to e to the I tx squared minus I sine of tx squared? Is this correct? No, that's wrong. That is absolutely 100% wrong. And instead, if I use the real operator, real of e to the I tx squared, that means that I've only mean this part of the integral, or this part of the expression here, the real part, cosine of tx squared. Thus, with this remark, let's go and write this integral again. I prime of t equals the real part of the integral from 0 to infinity e to the negative x squared times e to the negative itx squared dx. Oh, sorry, plus ix squared. And my I prime of t is going to be the real part, the integral from 0 to infinity of e to the itx squared minus x squared dx. And again, I prime of t is the real part of this integral e to the negative x squared times 1 plus 1 minus it dx. So I get this integral right here that I can work on it, and this integral is a little bit hard to solve it, but it's a Gaussian integral, generalized a little. Here I'm gonna define I as the integral from 0 to infinity of e to the negative x squared 1 minus it dx, and I another time as the integral from 0 to infinity of e to the negative y squared times 1 minus it dy. And if I multiply these two integrals together, I'm gonna get a double integral. If you multiply these two integrals, you gotta write them as double integral and multiply the insides. E to the, I'm gonna call lambda 1 minus it, e to the negative lambda x squared plus y squared dx dy. Here I'm going to do a substitution here. I'm going to say y equals xt, and if I differentiate dy, it's going to get x dt. So I'm going to do this substitution here. So we're going to use it with no polar coordinates. I squared is the integral from 0 to infinity of e to the negative lambda x squared plus tx squared dx x dt. And I squared is going to be, I'm going to be writing this integral again. This is going to be here, x e to the negative lambda x squared 1 plus t squared dx dt. And first I'm gonna be interested in solving the inner integral. Let's solve this inner beast here. So this integral x e to the negative lambda x squared times 1 plus t squared dx. I'm gonna define u to be equal to lambda x squared. I'm going to define u to be that 1 plus t squared, and du is 2 lambda x 1 plus t squared dx. And for next I'm going to multiply by 2 lambda 1 plus t squared, the integral from 0 to infinity of 2 lambda x e to the negative lambda x squared 1 plus t squared dx. Oops, sorry, times 1 plus t squared dx. And I can write it as 2 lambda times 1 plus t squared, this integral, e to the negative u squared, e to the negative u du. These two are going to merge together to form du. And this is our u here. And this integral, you can calculate it, it converges to 1. So my I squared is going to be the integral from 0 to infinity of, this is going to go down to 1 over 2 lambda 1 plus t squared dt. I squared is 1 over 2 lambda, the integral from 0 to infinity 1 over 1 plus t squared dt. And this thing here, this integral is arc tan of t from 0 to infinity. And calculating this limit gives us pi over 2, which is pi over 4 lambda, means I squared, and I is root pi over 2 root lambda, which means root pi over 2 times 1 over root lambda. And I'm going to substitute. if you remember here, we stuck here. So my I prime of t is equal to the real part of this thing here. Where were we here? The real part of root pi over 2, 1 minus it, since lambda is 1 minus it, to the negative half, and we can move this out here. I prime of t is root pi over 2, the real part of 1 minus it to the negative half. And if I integrate both sides with respect to t, I'm going to get I of t to be equal to root pi over 2, the integral of the real part of 1 minus it to the negative half dt. So here I'm going to define u to be, again, a u substitution. 1 minus it, du is negative I dt, dt is du over negative I, and dt is multiplying by I 2 times and dividing. I'm going to get I du over negative I squared, which is negative 1, thus it's going to be I du. So integrating this gives u to the negative half I du, which is I du, and it is going to be u to the negative half plus 2 over 2, negative half plus 2 over 2 times I, which is going to be 2 u to the half, 2I u to the half. When writing this integral I of t of root pi over 2, the real part of 2I square root of 1 minus it plus some constant of integration. These 2 and these 2 are going to go away, and I'm having I of t equals root pi, the real part of root 1 minus it plus c. And here, sorry, I forgot I here. I'm not gonna find plus c here for you and show. It's gonna make the video too long. But just a hint that I'm gonna give you is plug in t equals to 0, and actually I'm gonna show it. The integral from 0 to infinity of e to the negative x squared sine of x squared over x squared dx. T, plug in t equals to 0, makes this go away. Root pi, the real part of this, plug in 0 here makes this real part of I, which is 0, and thus our c is 0. Thus I of t is root pi, the real part of I root 1 minus it. And if I plug in I of 1, I'm going to get root pi, the real part of I root 1 minus I. Now, root 1 minus I square root of can be written as, we can write it in terms of complex numbers as root of root 2e to the negative I pi over 4. And if I move this one out, it's going to be e to the negative I pi over 8 root of root 2. Thus, I of 1 is going to be root pi, again, the real part of I e to the negative I pi over 8 root 2. I'm going to move root 2 out here. I of 1 is, sorry, root of root 2. Root of root 2 root pi. The real part of I e to the negative I pi over 8. Now recall the formula that I mentioned earlier. E to the ix is cosine of x plus I sine x. And e to the negative I pi over 8 is cosine of negative I pi over 8 plus I sine of negative pi over 8. The negative here is going to be absorbed. So I'm going to have, we shouldn't have this pi here. It's going to be cosine of pi over 8 plus I sine of, sorry, minus I sine of pi over 8. And if I plug it back in, I'll have I of 1 equal to root of root 2 root pi. The real part of I multiplied by cosine of pi over 8 minus I sine pi over 8. Now, if I move and expand the I here, I'm going to get I of 1 to be root of root 2 root pi. The real part of this integral, I cosine of pi over 8 minus I squared sine of pi over 8. And write it more cleanly. It's going to be I cosine of pi over 8 plus I squared is negative 1, thus we're going to have plus sine of pi over 8. Now, what is the real part of this expression here? This part is imaginary, thus we're going to only have to take this part. Thus, I of 1 is root of root 2 root pi sine of pi over 8, which means it is equal to root of pi root 2 sine of pi over 8. And therefore, the integral from 0 to infinity of e to the negative x squared sine of x squared over x squared dx is root of pi root 2 sine of pi over 8. And that is the final form of our integral that we obtained. Hope you enjoyed this video. If yes, please like and subscribe and share my videos, and I'll see you next video.